my name's Paul and this is PJT Ventures. Join me while I ramble on like an empty dump truck. Today's ramble, we are working on the Letourneau model DP Tournapull scraper. Now this scraper is kind of special because it has all electric controls. So the steering, the up and down, the eject and the apron are all run by electric motors and cable winches. Now we're just kind of getting into the electrical side of things. Now the first thing that I found is this is the rectifier. So this I think changes from AC to DC, and I'm not that familiar with electronics or with electrical things, but I am familiar with something that's broken, and so that can't be good. This is an oil-cooled rectifier, so there's transformer oil or I think dielectric oil in here. So we're going to pull the starter off, we're going to pull these leads off, and then we'll take this lid off and we'll see what's going on in there, because I can't imagine that this is good. Right now I have put a multimeter and tested, and there's 24 volts coming from the battery system that feeds this, and then there's something that happens with the 24 volts that then excites the AC generator somehow. I'm not quite sure how it all works, but we'll get to the bottom of it. But first things first, we're going to pop this cover off and we're going to see what is going on inside here, because that can't be factory. Okay, so I disconnected the battery, and just so there's no electrical shock issues. And now we'll see. Looks like that's on needing a little bit of attention anyways. We might not need to take the starter off. Maybe just with that out of the way. We'll see. I did look down in here and there is oil in it, but I'm sure with this being loose, there's probably water in the bottom, sadly. This box is welded right in, and the manual does say to periodically, every 5 shifts or something, check the level of this and take it out and clean it and replace the oil from time to time as part of the service. So they did design it to have a certain amount of serviceability, so I'm hoping that we can just maybe weld that back together or replace that little part. But anyways, we'll soon find out. That doesn't feel good. That feels like it's turning something in there. Maybe we'll take the lid off first and see. Better grab a wrench. Yeah, that doesn't seem right. That's a different size. Nope. Okay. Change of plans. It's always a frustrating feeling when you start loosening a bolt and it gets looser and looser, but then all of a sudden, even though it's not touching anything or it has any more compression, it starts to get tight, which means the threads on the inside are funny. So it looks like the threads have some corrosion on the inside. That's never a good sign for the sealed case that's supposed to be sealed and full of oil. I don't want to just use one of those an impact tool and just have it snap off. So we'll just take our time. Okay, we got the bolts out of the lid. Time for the next big reveal. Oh. Probably should have gloves on for this now. Well, oh, don't drop that. Okay, look at that. I'm glad I didn't turn on these. I'm glad I didn't turn on these too aggressively, because I don't know if you can see that. Because had I turned on those, get the camera here. Had I turned on these too hard, I would have maybe done some damage, but we'll get this all out and cleaned up and see what's actually in there. So we will take the starter out. I think I have it all ready. It looks big and heavy. Oh, arm curls for the day. Okay. Well, they said be on the lookout for green oil. You know, it might not be that bad. I bet you we can clean this up. We'll let this drip. This is all iron oxide that has probably been attracted to these plates as this got old. I'm sure even just me driving it and having the batteries hooked up has drawn current through all of this. The generator's never turned on. I don't dare turn the generator on until I can get the motors disconnected up there, because the motors are all seized. But yeah, we'll get this cleaned up. Don't drink the Kool-Aid. Okay, we got the most of the oil sucked out of there. Now we're going to scrape it clean. See if you can see in there. There's lots of grime, lots of rust, probably some water that's mixed in with the old oil. I got these these are from your local veterinarian store, and they're pretty good at keeping your coveralls clean. Okay, so it's the following morning, and I was able to, I got it all clean and dried. I filled it with new oil. All I had to do with this is I just found a nut that matched this threads of this stud, and then on the inside I just put the nut here on the bottom. I don't know if you can see that. And then filled it with oil, and now we'll just start the testing procedure. So I'm not going to seal this down yet until we've seen what some of the voltages are, but I believe as long as the plates are submerged with the oil, it should provide enough cooling. And who knows what we're going to find. I realize this is all pretty rough and has to get redone, but there is a part of me that does want to see what is viable and what isn't. So we'll take it slow. These were all the old original leads, and the stuff was just, it's been, I don't know if you can kind of see here, but it's been baked or it's been shorted, and I mean it just cracks. So we're gonna put new wires and connectors from here up to the transformer and to the generator. And that'll be our next little task, to see if we can get some current through there. So I got some of these little copper ends, and I got some heat shrink that we'll put on, and a bit of flux, and then maybe something like this. See if we can. I'm not a big fan of the crimping ones. I don't think they're, look at that. Yeah, I don't really like those crimping ones. I think for this much voltage, I think it's probably safer to do it with the soldered connection. I'm probably doing all sorts of things wrong, but anyways, it is what it is. Oh, look at that. I'm so good, I soldered it. I soldered it to the alligator clip. And then my alligator clip came apart. Well, you're never good at something the first time. But we'll get there. Okay, now I just need to do that. I just need to do that like 50 more times. That wasn't so bad. I really don't like wiring. I haven't done a lot of it. I'm not really that fond of it, and I think I'm going to be doing a lot of it. So I got to change my attitude and got to put in some effort and see if I can make it a positive experience. Oh, it almost went too tight there. I wonder if I'll let that one cool. Oh boy. You should have listened to the little voice. Looks like I should have used the size up. Oh, I'm learning. There we go. Okay, so we're on to the transformer. There's 6 leads that feed from the rectifier up to the bottom of the transformer. I believe one set goes into the primary and a second set goes into the secondary. You can see underneath here, I'm not sure which is primary and secondary, but so we got to replace these leads. So hopefully we can carefully cut these off and resolder the new wires that lead down to the rectifier. You can see here, these are, look at that, like they were rubbing. Who knows if the rectifier is truly damaged or if the transformer is damaged, but we're going to try. So we'll get rid of all these wires. I was able to get the transformer up, and these guys luckily are loose enough, but I don't want to have to cut these ones off. These ones go down into the generator, and I'm hoping that I can leave those ones alone. There's a slip ring down there as well that also needs to get its lead replaced. These are the 3 legs of the 3-phase, and then they go up top here, and then I think there's these are DC that tie into this right here. So these guys will all get replaced. This will all get replaced. I'm going to try to leave this for now. This seems to be in fairly good shape. We'll see what it's like once it gets back to the main switches. But I did get a wiring diagram here. So this has been a big help. So here's the rectifier up here. Comes into the transformer there. So that's yeah, that's a big help there. So we'll keep on keeping on. Okay, so I put a piece of plywood over top of the generator and a big heavy towel, old towel, and then I also put these little, just had some chunks of some thin metal to try keep solder from dripping into the generator or into that, and then also just kind of keeping everything from getting burned. So I cut back the wires until I got past the factory connection from the solid wire that comes from the transformer to the flexible wire that went down to the rectifier. So hopefully I'll get a good connection there. I put my heat shrink on ahead of time. I don't know if I'll get it over top of that lump now, but okay, first ones we got soldered. Give these a quick heat shrink. Okay. Those look pretty good. We'll get these, maybe some of their own individual loom. That's such a funny word for electrical wire coverings. I always just thought it was me standing over top of someone. Okay, so I have rewired with new wires and terminals the primary. I believe this is the primary transformer. This is the secondary transformer. So I've run new wires up from the rectifier and soldered them onto the bottom leads of the transformer. I also found a short in the original wiring that leads to the three-phase switches. So I believe it comes, these are the three-phase lines coming out of there. So this guy had a short. So I've just isolated him for now. So we just kind of have the first stage, the rectifier to the transformer, replaced. And we of course cleaned out the rectifier's tank, put new oil in it, and very gently cleaned those plates. But now that I put everything back together and when I run it, I still am not getting the transformer to produce very much three-phase. So I'm getting like maybe 15 to 30 volts of AC three-phase. Now all three, depending on how I test each two, they're all reading almost near identical, but I'm not getting this enough excited DC to the slip rings, I believe. So I don't think the rectifier is actually feeding the transformer correctly. Now, there is some more testing that I need to do, but I have to set up a a way to draw DC current through, and I need to take like 20 and 30 amp test ratings, and so my little multimeter is only, I think, a 10 amp rating, so I kind of got to figure something out. Back in the day, Letourneau had a dedicated testing unit that could pull varying degrees of load or current for both the AC and the DC systems. So I still kind of got to figure that out. So it's not just as simple as replacing the wire from the rectifier to the transformer. Now, one thing that I did check is, so in here, this is the, of course, the switches. So these are run independently through the 24 volt DC system. Then, of course, the 3-phase power comes in, and these switches are run through the DC system. But then, of course, this is your 3-phase 300 volt AC system that then runs the actual motors. So I isolated everything else with the exception of the steering motor. So these are the this is the steering left and steering right, or vice versa. But this is the steering motor circuit in 3-phase. And we'll just go up here. I'll show you. This is, maybe I can get this up here. So this is the motor and braking system. So there's AC magnets that, let me see, there we go. So this is the brake system. So these brake discs all spin or don't spin depending on how this is either being held up by these springs or pressed down by the magnets. So when the, let's put these down. So when the steering motor gets a signal, all these magnets pull down, release the brake, and then the motor is able to turn. The motor is able to turn either way. So right now, I believe this motor tests out that there's no faults and no shorts. So I think this motor will actually operate. It turns freely. It always was free. There's no shorts in the magnets. I think just because of the way it was kind of covered. So I have the brake system completely removed just in case these electromagnets don't pull this down. But for the time being, this seems to be ready to go. In here is some limit switches for the steering. So when this when this neck twists back and forth, it clicks on these limit switches, and this has an offset shaft that sticks up that's adjustable for the steering's limit switches. But this eccentric shaft here, I don't know if you can see down in there from this eccentric shaft allows you to adjust where this is in relation to the neck. So these limit switches are what then tell the motor to stop turning when you get to the end of your pivot or your turn on the neck here. So I think this motor is going to be operational, but we just need to get 3-phase to it. And so far that has been a bit of a mystery so far. I thought that if we got new wiring we could pull it off. I thought if we got that rectifier cleaned we'd get the generator to go, but for the time being we are not quite there yet. But I have a call to a couple of people at the local generator / welder / electrical motor rebuild place, and I think hopefully we'll be able to get some insight into maybe changing how that rectifier works, or getting a different type of rectifier in there, or some type of alternative. I did some reading about some VFDs and some various options that we have, but anyways, so it continues, but it's a slow process now, not quite as fun as the belching diesel and and simplicity of changing oil. I did put an inline heater just so I could have it warm. So I just put this this little kind of inline coolant heater I pulled off of here. I wasn't quite sure exactly how this whole system works, but so I put the intake down here, and then in the back here, I don't know if you can see that, in the back of the head there is a port, I think, that goes in where the head gets coolant that goes up eventually to the radiator. I believe there's a thermostat somewhere in here. So I was going to maybe go off of that one, but that one was pretty seized, and I kind of like the idea of the coolant coming from here and going up to there and getting as much of the head as possible. I also did put a new temperature gauge while I had this open. So you can see here, here's where the temperature gauge went. That was a factory temperature gauge right there. And then I just ran the inline coolant heater to here. I put a valve here because I didn't know if this would maybe affect how the regular engine's circulation system would work in relation to the thermostat. So I just put an inline valve here, so when it's not being warmed prior to running, this can stay closed. Sorry, this can stay open when you're heating it before you start it, but once you start it, then this can stay closed and the regular system can operate as it should. I put a little air bleeder to get the coolant out of this end, just a little fella here to make sure no air locks happen. But so that thing worked really good. I could then just leave that going and could come and start the engine any time, and it wasn't so cold-blooded then. So anyways, I still believe that the rectifier is our issue, and there's a few other things that we can do in the meantime. So I'm going to try a few more tests and see if we can get some power to the you don't need to be in there. See if we can get some power up to the generator in there. So anyways, those wires are just kind of roughed in for now, but we'll get it cleaned up as we get more done. So not quite as exciting of a episode as I would have liked. I would have liked it to have been where I was driving it around and the steering was working. But anyways, we'll keep going. And if you guys have any suggestions as to maybe how we go about getting around that old rectifier, that'd be great. Put it in the comments, or if you had any experience with it, let me know. Otherwise, thanks again for watching, and we'll look forward to seeing you on the next one. Bye for now.